Hello again. Welcome to my second part of my tutorial on how to control lasers with TouchDesigner. The first part was more about the general setup and how to set up your TouchDesigner patch, how to install drivers. This is specifically to controlling lasers over the AVB protocol. My second part of the tutorial is more specifically about the laser chop, the new chop that Derivative recently released, and it kind of replaced the scan chop which was there before, and the laser chop was developed with the great help and expertise of laser animation Zollinger. So yeah, this tutorial is more about the laser chop itself and how it actually works. To understand the laser chop and to be able to optimize its parameters, I think it's important to have an idea of how a laser actually produces its images. So if we see these triangles, for example, if we see a laser drawing a triangle onto a projection wall, what we do need to have in mind is that a laser actually only outputs a single point, so one beam at a time. It's not outputting a line or a shape. It's just one point that it's traveling, and it's traveling so fast that it kind of draws a triangle, and it looks for us as if there was a static triangle, but it's actually one line that travels so fast in a shape of a triangle that it seems like a static shape. So basically, if we want to achieve an image like these two triangles, what eventually needs to be sent to the laser chop are these 6 points A, B, C from shape 1 and D, E, F from shape 2. And essentially what we do need to describe with the parameters of the laser chop is how this one single beam that travels we need to describe how it should travel between these points. So one parameter is the step size, and basically it describes kind of the density of the path from one point to the other point. So between A and B, B and C, C and A, and so forth. So the step size kind of declares how many points the laser travels along between two points. And on a straight line, basically you can make as less points as possible, but it does make your beam a little less bright. So you need to find a good parameter value here. The next important point is the word vertex hold. So basically it describes how long should the laser stay at each point. And if it's on a straight line, you basically don't want the laser to stop at any point. It just should kind of travel along these points. But because it's really a physical thing moving inside of a laser machine that kind of directs the laser, it's really physical mirrors. They can't just go from, it can't make too steep curves. So basically what you need to tell the laser is to stand still on, for example, the point B, because otherwise you will get kind of just curves in the corners because the laser just continues to travel to point C. So basically what you want to have in these angles is that you want to have a nice and big vertex hold, so you can get really nice pointy edges in a triangle. You can't stay in these edges for too long though, so that's also something you need to find out. I guess every laser is a bit different as well, so yeah, that's one thing. So step size and vertex hold, they are kind of there to kind of describe how the laser draws the shape. And another important aspect is how the laser should travel between the shapes, so between our triangle 1 and 2, and these are the kind of blanking points or blanks. So the laser is traveling from A to D, and in that moment the laser is off. So it actually travels, but we just turn off the light. That's also another part of the laser chop, is how to deal with these blanking delays. But basically what you want to describe is also the step size in these blanking phases. So at the end you see all these dots, which are points at the end. So each laser has a specific amount of points that it can travel within a second or within a frame. The laser I'm using has 96,000 kilohertz, so basically you can describe 96,000 points to the laser. Of course there are some more details that you can be aware of, but I think just for starters that's a good overview in just getting to understand the laser chop and what you need to have in mind if you play around with the parameters. So let's start with our example, displaying 3 triangles, and as we can see, we do see our blanking points and our corners are rounded. So what we definitely need to do is going to the laser chop and actually working with the vertex hold and making the vertex hold in the corners much higher. So you can see if I just raise the vertex hold, we can get much cleaner corners. We can even go a little bit higher in these corners. So yeah, we can get nice and steady corners, maybe just even having smaller step sizes in between, but definitely making the corners as sharp as possible is what we are aiming for. So actually now the shape of the triangle looks kind of decent, which is okay in my opinion, but still you see the blanking is our problem here. So yeah, here you can see the blanking is there, but they're probably not enough, so you need to go to the color parameters in the next step. So here's the color parameters, and what we need to do is raise the pre-blanking of delay a little bit. Please read in the wiki of the laser chop from derivative. They have some good explanations about post and pre-blanking, which you need to take care of here. But basically it describes on when do you start to turn off the laser, and before the blanking starts and after the blanking starts. You also have the blanking step size, which you probably need to put as high as possible, so you don't lose kind of your resolution in total. So yeah, I think if you fiddle around with your parameters, as I said, I think each laser has its own little characteristics. So yeah, there's no rule kind of that I can tell you. But yeah, what I made for you is this kind of output trail, and it kind of shows you it adds a Z dimension to the travel path of the laser. So you really see the laser's actually drawing these triangles kind of 2 to 3 times per second. And you can see these kind of ladder-ish moments, and these are our vertex holds. So kind of in these corners, the laser kind of stays at these points. You can see that there's blanking in between those shapes where there's kind of these invisible ladders. So yeah, I think this kind of illustrates good what the laser is doing and what you are kind of telling the laser to do. So he's kind of rotating around these triangles and tries to draw them, and you need to just make sure that the laser stays on these corners as long as it needs to, but also travels to the next shapes as fast as possible. Along with this trail preview, I just wanted to show you one or two other things that you can find in my GitHub patch on this tutorial. So the one is on using the copy sub, which becomes quite a handy node when working with lasers, especially when it comes to stamping. So this example shows you on how to use translating and scaling in the copy sub and doing and using stamping, which kind of leads to doing some very nice, very quick modulations on different shapes. And the other one is actually a very nice tool in how to color the laser after leaving kind of the subworld, because coloring in subworld isn't really handy to do at this point in TD. So kind of what I made is this component where you can input the values that you get from the laser chop and input another top, which kind of colors the dots that the laser chop outputs. So I think that's two handy little aspects that you can find in the GitHub, and I'm happy to see some nice results. That's it for part 2. Thank you very much.